Good afternoon, everybody. My name is Charlie Nicklin. I'm the Chief Executive at IAgrE, and I'd like to thank you all for joining our March lunchtime lecture. I'd like to welcome Gareth start again. I'd like to welcome Gareth Ellis from Cranfield University as our guest speaker today. Gareth graduated from Silsoe College back in 1980 with a degree in agricultural engineering. He then spent 16 years with ADAS, mainly in horticultural engineering, but latterly renewable energy. In '96, he moved to the National Energy Foundation and headed up their work on renewable energy. After a brief spell with the environmental consultancy, he returned to Cranfield in 2008 and became the Energy and Environmental Manager at the University Estate. In today's lecture, Gareth will be talking about the work he has been doing to reduce the environmental impact of the university and how it intends to meet its 2030 target of net zero carbon and zero avoidable waste. So just before Gareth starts, you're all currently muted. If you would like to ask questions, then please use the chat function at the bottom of your screen. And then at the end of the presentation, we'll unmute you so you can ask your question. Okay, no further ado, over to you, Gareth.
Thank you, Charlie. Right, let's see if I can make this work. Just a few slides, just to, as Charlie said, it's really an overview of the sort of things we've been getting up to in Cranfield over the last 10 years. And then just looking forward briefly to what our plans are for the future. So I've subtitled this talk, Saving the Environment and Saving Money Too. The latter bit has been particularly important over the last 10 years. And we, to some extent, have achieved it. Going forward, I think it's going to be more difficult, but I'll get to that at the end. So I'm going to go over what we were trying to achieve 10 years ago. I've been here since 2008, so just a little bit longer than that. How carbon in particular has been our focus, not least because it's also enabled us to save money as well. Some interesting things about how we've tackled biodiversity on campus, or how we came about to tackle biodiversity, and a little bit about management of the environment. So some of you will be very familiar with Cranfield, but some not, I guess. So just a brief overview of what we've got. Cranfield is quite unique in that it's a postgraduate only university. We don't have any undergraduates at all, which is interesting. I actually was an undergraduate at Cranfield all those years ago, but it's gone back to being just purely postgraduate, heavily research based, heavily business industry based. So we have a School of Management and we have some technical schools, plenty of science and technology at Cranfield, no arts, unfortunately. And we have an airport. So the university actually owns the airport. So we have quite a big campus and we have an airfield as well. The campus itself is a bit like a small town. In fact, it's got all the elements of a much larger town. It's got its own airport for starters. It's got things that go with an airport. It's got still some working aircraft hangars. It's got its own fire brigade. In the main campus, we've got laboratories, workshops, industrial scale workshops. We have lecture space, obviously, being a university. We have offices, there's shops, restaurants, a sports hall and gym. There's 2 hotels. There's the residential halls. We've actually got houses on the campus itself. So we have family houses, particularly for the older postgraduate students. They'll come with their families. The campus has its own sewage treatment works. We have our own waste collection service. We have our own bus depot. We've even got our own electricity network, which is high voltage. And we've got district heating, which covers the main part of the campus, but sadly not the residential side. So when I joined Cranfield in 2008, I joined to be their first ever full-time energy manager, because they had just set the ambition of achieving a 50% reduction in carbon. So my first job was to actually try and work out how they were going to do that. I'm still working on it, to be honest, but we've made a lot of progress over the last 12 years. And the target was to reduce by 50% by actually now, so our current academic year, 2020-21, against the 2005 baseline. 2 years into working on that, the university decided to broaden its ambitions and aims to look at other environmental issues. So a number of other targets were added to the list. So we had a waste reduction target coupled with a recycling target. We also had targets for water to reduce water consumption. Later, we added a target for biodiversity to look at, could we increase the area we set aside for biodiversity on the campus. And we also were looking at sustainable travel. It's actually a planning requirement that we have a travel plan for the site. So this was added onto our environmental targets to have a target to reduce the amount of single occupancy car commuting over a 5-year period. There's actually a typo there. It should say from a 2012 baseline, not 2021. So a number of quite ambitious environmental targets. There were a few others as well, but they were really minor details. These are this was the main thrust of what we were trying to achieve. And to some extent, Cranfield was, certainly with carbon, leading the way, in the sense that we set a target before many other universities had. But by 2010, it became actually a government requirement that a university had a target. They didn't actually say what the level of target had to be. And a number of universities, I think, would have struggled with a 50% target like ours because they were growing quite fast. As it was, Cranfield itself was growing quite fast at the time. And we still continue to grow today, but perhaps not at the same rate. Sorry about the busy slide, but this is just trying to give you a flavor for what we actually achieved over the last 10 years. So with energy consumption, kilowatt hours, it looks like pretty much we haven't achieved a lot because it's pretty level. Perhaps it's dipped down a bit in the last few years, but as I'll hopefully demonstrate in a few slides' time, this is against the backdrop of the university growing, which it has in terms of turnover and floor area. So to actually achieve the status quo in terms of total kilowatt hours has been a reasonable achievement. Perhaps what you'll hopefully start to recognize with that first graph on the left-hand side is that it's showing a different mix of energy as we go forwards. So starting out with quite a bit of electricity, which is the blue, and a big chunk of orange, which is gas, and then oil and biomass on the top, alongside other, which is largely vehicle fuels. Similarly with cost, cost hasn't gone down dramatically, but as I'll demonstrate in a little while, that's a real achievement because energy prices have been going up over this time period, and bearing in mind our consumption hasn't dropped that much, to actually keep costs on a level has been quite a struggle. And then last but not least, because this is what we're trying to achieve, carbon has reduced significantly. So there's been a huge reduction in carbon. So how have we achieved that, even though we haven't dropped the kilowatt hours? This starts to tell the story. The top graph is the one I showed in the previous slide, and that's what we've managed to achieve over the last 10 years. The bottom slide is what I would call business as usual. So that's saying well, what if we actually kept that previous or starting energy mix in 2009 of roughly 40% electricity, 50% gas, quite a bit of oil, and a bit of vehicle fuel. And also we actually look at what the impact of turnover would be. So it would have marginally, maybe about 10% increased our overall kilowatt hours. But in 2010, we installed a large combined heat and power unit, gas fueled. So that explains the drop off in the top graph in electricity, the blue, and it explains the increase in gas. So effectively what we did was we pretty much halved the amount of electricity we imported to the site, and we dramatically increased the amount of gas. The consequence of that, I'll show in another slide. We also then did quite a number of energy efficiency measures, lots of pipe insulation, building insulation, number of other energy efficiency measures. And in 2014, we installed a large biomass boiler for our district heating. And that's, in a sense, replaced oil, or more than replaced the oil. We did further energy efficiency measures, particularly with lighting. Lighting is a big part of our energy consumption on the site. And it's quite dramatic what you can do by replacing old fluorescents with LED lights and better controls. And finally, the last big investment we've made has been in what I would have to call a small solar farm, but nevertheless, it's a megawatt and it generates about 5% of our electricity. We rely heavily on something called the Salix Energy Efficiency Revolving Fund. And at the same time, we expanded our district heating to take on more buildings onto the district heating, and we largely phased out oil heating. This is the combined heat and power unit we put in, built, manufactured by a company called MWM that used to be part of the Deutsch group. So in my mind, it looks like a tractor engine anyway, albeit a very big one. And it's served us really, really well. We had one major refurbishment of it a couple of years ago, but it's been running now for 11 years. And it's been very, very reliable. And we've pretty much run it as much as we possibly can. I think when we first put it in, we were being advised by consultants on the feasibility of it based on it being heat-led. And we don't use much heat in the summer, so that would have meant it only running during sort of 2/3 of the year. In actual practice, because of the price of gas and the price of electricity, we've run it throughout the year. And we have to accept the fact that we're not making use of the heat in parts of the summer, but economically, even environmentally to start with, that was the right thing to do. So we really maxed out on this combined heat and power unit. The biomass boiler we installed, this is a French company called Compt, physically quite big, a sort of moving grate wood chip boiler, just short of a megawatt. We only run this obviously during the heating season, and in a typical year we would aspire to burning about 1,000 tons of wood chip. And the wood chip, we do source that locally from LC Energy, from a depot in Hertfordshire. It arrives on a large Arctic lorry, 25 tons a load, probably 2 or 3 loads a week. And we use we dump it onto the floor. So you see the picture there of it with a lorry with a walking floor pushing the wood chip onto the floor. And we have something called the Jarvo top on loader, which when we purchased that back in 2014, I think it was quite unusual to use that for wood chip. It's used largely in the horticultural industry, certainly in this country, obviously commonly developed in Holland. But the Irish were starting to use this as a means of handling wood chip, and it is very effective. It's effectively an automated system for scraping the wood chip onto a moving conveyor, then into the wood boiler, making it completely automated. And it has the advantage for us that any moving parts are easily accessible. The big issue with biomass systems, and our own experience, is that they're quite complex. Even though it might seem a simple system, there's plenty of things that can go wrong. So your wood chip can be too dry and dusty, which fogs up the sensors and stops the thing working. It can be too wet, and the burner, the boiler can't cope with it. And also the quality of the wood chip has to be just right. Otherwise, you might put too much pressure onto the screw auger that's pushing the wood chip into the boiler. Lots of things potentially can and do go wrong. And I would have to say, in the 5 years we had this boiler, we've only had one season probably where it went the whole way through without a fault. We usually lose a month or a couple of weeks here and a couple of weeks there, somewhere during the winter, with something breaking down. So it's probably paid its way, but I'm finding it very difficult with my senior management to press the argument for us to put another wood chip boiler in, because too often we get issues with it in breaking down. Moving on to a more straightforward technology, solar panels, no moving parts at all. So wonderful. That's not to say that it can't also have its issues. And we did have, fortunately, we put these solar arrays in with distributed inverters, the bit that converts it from the DC current that's produced into AC. When we went out to tender for this system, we had the choice between a centralized inverter where all the DC would come back to one point, and then it would be converted into AC current to be transported into our grid. Fortunately, we went for distributed inverters. I say fortunately because we have had one that's managed to burn itself out. But as the company who supplies the inverters is just down the road in Milton Keynes, that certainly wasn't an issue, and it was replaced that day. So it's a megawatt. It covers 1.6 hectares, rated at 1 megawatt, and produces 1 million kilowatt hours per year. In the first year, it produced almost 1.2 million. It was quite a sunny year. But on average, so it will vary from year to year, but on average, it will produce 1 million, which is about 5%. And as our electricity consumption goes down, probably just over 5% of our consumption. But that's over the years on average. There are certainly days in summer weekends where we are in danger of the solar panels exporting from our site. If our consumption drops to a low at a weekend, and remember we've got the combined heat and power unit running as well, we certainly have to ramp the CHP back to prevent any export. And the reason why I say we want to prevent export is that we're not allowed to export. So the local district network operator will not allow us to export from our site. We're right on the edge of their network, and the local infrastructure can't take it. I suppose there's also an economic argument. I mean, to us, we sized it at megawatt because of that, but also it meant that we used every last kilowatt hour ourselves, and that makes the electricity that's produced is that much more valuable. And if we were trying to sell it, it's probably worth 3 or 4 times what it would be if we were selling it for export. So that's where the solar array is. It's on the far side of the airfield from the campus, but we have an 11 kV cable connecting around the top of the runway, actually, back into the campus, and that works fine. So every last kilowatt hour that it produces serves all the buildings on the campus. And I like to think, and I keep telling the various powers that be at the university, that we could double or even triple the size of this array. We had obvious constraints because of the airfield, and the airport director was particularly concerned about things like glare. So we had to have various studies done before going for the solar array, and obviously we had to go through planning permission as well. But the locals in the village were quite happy with it. The other constraint is the proximity to the runway, but I've seen plenty of airports, including those in the UK, with panels much closer to the runway than this. So I certainly have ambitions that we would expand upon this initial array. And in fact, we put in for some funding before Christmas to see if we could fund a 50% increase this year. The bread and butter of saving carbon, though, has been our energy efficiency revolving fund. This was pump primed with an organisation called Salix, which is an offshoot of government set up to help the public sector by providing interest-free loans. And they've established this system of a revolving fund. So they put in half the money, we put in matching money, and we had an initial pot of funds for energy efficiency projects, which had to meet certain criteria, that they were carbon saving over their lifetime, and that they had a payback period of less than 5 years. So with that initial pot, we identified a number of projects, a lot of them insulation projects, lighting projects, building control system projects, verified that they got a 5-year payback. And then with this revolving fund system, you have to make sure that the energy savings go back into the pot. So doing that, it means that certainly in the first year, you've got 400k to spend. You spend all that, but then as the money and the savings come back into the pot, you end up with roughly 20–30% of that initial pot to spend each year going forwards indefinitely. And we've had the system running now for 10 years, and we've revolved that pot over 3 times, almost 4 times, spending almost £2 million and saving over 500k an annum in total, with about 82 projects that we funded through this system. And it's been crucial actually for us to make that incremental, probably about a 10%, 12% increase in efficiency per meter squared for the site as the site has grown to efficiency across the site. If it had been left to what had been given to us in our energy budget, we probably wouldn't have been able to keep that momentum going. But the fact that we got this pot, which was ring fenced, made a huge difference. So what was the impact of all this technology on our costs? Well, I suppose actually the biggest impact was that strategic decision to invest in a combined heat and power unit at the outset. Because what that did was it reduced our exposure to the fact that electricity prices were increasing rapidly. And for us, they pretty much doubled. So the electricity we import is pretty much double the price it was 12 years ago. And that's why we run the CHP as much as we do, because it's very efficient and it can convert gas where the price hasn't changed. It's gone up, it's gone down, it's gone back up again, but largely it stayed flat over the 10 years. So that strategic change to generate our own electricity using gas has meant that our costs have stayed largely level, if they've gone down slightly. Whereas if you look at the bottom left chart, business as usual cost, if we'd have stuck with importing all our electricity, then our costs would have doubled. And the other chart, as I say, is just showing, you can see roughly a sort of 10% decrease in kilowatt hours per meter squared, both for heat consumed and for electricity. So through that energy efficiency fund and some other interest-free loans we managed to get from Salix, we've managed to put in a number of energy efficiency projects which have kept a lid on the overall kilowatt hours and stopped that going up as the university has grown in size. One word of warning though, if I've got you interested in combined heat and power, particularly if it's gas fueled, and that is that prior to roughly 2014, 2015, it was much cleaner than the grid. So not only was it cheaper, but using gas and the efficiency of that engine, we were able to generate electricity with a lower carbon factor than the grid. So this graph here, which is looking at CHP and carbon factor, the grid carbon factor was above 0.5 in 2009. It hadn't changed much by 2014 either. But since then, as the coal power stations on the grid have closed down, as there's more wind farms and solar farms on the grid, then the carbon factor has plummeted, and it's probably half what it was back in 2015 now. The CHP had a carbon factor of about 0.32 for electricity, assuming that it depends how you account for this, but if you put some of the carbon onto the heat produced, which is similar to what the carbon factor would be if you produce that heat with gas, then the remaining carbon on the electricity is about 0.32. So great, before 2015, saving a shed load of carbon by running the CHP, even if we weren't using the heat actually. Since 2015, there's been a changeover point which came a couple of years ago, and we're now into a situation where we're saving a lot of money by running the CHP, but we're also not helping our carbon footprint. We are still managing to get the carbon down, but that's because of the other measures that we're putting in place rather than the CHP. So this is our big issue that we've got going forwards, is how are we going to replace the combined heat and power unit? Talking to Bob earlier, it'd be very nice if we had a large AD unit and we could use the gas from that to run our CHP. Unfortunately, we've looked at the feasibility of that, and we don't really have the site or the access to the resources to do that. Certainly not at the present moment, the present state of the technology. Just to sort of demonstrate that we are pretty much at our target. So baseline was set in 2005. Actually, the carbon emissions were going up. This is a graph of carbon emissions. The carbon emissions were going up, and the dashed line sort of shows what would happen with business as usual. If we'd carried on as we were, then carbon emissions would have continued to rise. But in 2008, strategic decision to have a target to reduce carbon and invest in the combined heat and power unit in 2010, and our emissions started to tumble. And by last year, we'd got to 43% reduction. Happy days, and almost on target for the 50% this year. And then COVID hit, which you might think intuitively would have helped us, because less activity on site, less electricity being used, great. But in practice, what's happened is that the university has made the decision to have as much face-to-face time for students as possible. So we've had to do that socially distanced. So office space converted into lecture space or seminar space. And that lecture space has to be ventilated to be COVID safe. And we have to heat that ventilation, and we're not allowed to recirculate. And what's happened is our gas consumption this last year has gone up. So I'm not so sure we're going to meet the target anymore, but we almost did, I can say, if the time comes. Conscious time is going on, and I just want to sort of share one or two other things we've been doing on campus which might be of interest. The grounds came under my responsibility. So having joined as energy manager in 2008, I became an energy and environment manager in 2011 with a team of specialists looking at environmental issues for the campus. And one of the things we took on was the grounds contract. which is very helpful if you've got a target for biodiversity. So in those days, well, and I suppose to be fair, it's still the case, we have plenty of examples on site where you can easily see that Cranfield University is based on an old RAF wartime base, and the management of the grounds was very much on a military basis, nice and neat and tidy, short back and sides. And that was everywhere. But looking at it from an environmental point of view, we started to wonder, well, what can we do to make things a bit more interesting? And one of our keen naturalists on site pointed out that we have quite a number of bee orchids that come up across the site. Bee orchid is a very interesting flower. It imitates a bee to attract other bees to pollinate it. And it's quite an interesting flower, and it just happens to be the county flower of Bedfordshire. So quite an iconic flower to make a fuss of. And it gave us the excuse to start cordoning off and declaring areas, conservation areas for the bee orchid, which meant we no longer had long grass, short grass everywhere. We had the opportunity to have some long grass where we were protecting the orchid. And we've got one or two other interesting orchids on site as well. And this is a common spotted orchid. So if we let the grass grow in places, then we get some interesting wildflowers that come up. So that was one thing. We also had an approach from the academics who were doing a research project for NERC, and that was looking at biodiversity ecosystem services, and in particular the impact that wildflowers might have, and green spaces in general, but wildflowers in particular, on urban populations. So they had planted some wildflower plots in Milton Keynes, in Luton and Bedford, and they also wanted to plant some at the Cranfield campus, which we were very happy to facilitate. And that created some real interest from staff and students. And again, that gave us the excuse to think about doing the same elsewhere on campus. So not treating it just as a research project, but seeing if we could do it to make the campus a little bit more interesting. And we picked, with one of our first plots to do that, we picked right in the banks, smack in the middle of campus, in the busiest thoroughfare, next to the IT building, between the library and Vincent building, where most of the lecture space is, and not far from the CSA bar. So quite a busy place on campus. A very small patch, but had a huge impact on people. The color and display, but also the activity of insects on that small patch was a real talking point. And it gave us the confidence then to start spreading this everywhere on campus. And so far, we've not had any kickback. It's just grown and grown. And each year we start planning about, well, where are we going to put some more plantings? Where are we going to have another area that we don't cut the grass anymore, and we just let it grow and see what comes up? And we started designating these spots biodiversity action areas. And obviously we went further than just flowers. We started looking at how we manage the bits of scrub that we've got, the small woodland, which we've opened up for people to access. And year on year, it's just grown and grown. In 2013, we set a target to increase the areas by 50%. By 2015, we'd almost trebled them. And since then, we've probably trebled them again. So I think it's something like 12% of the area of the campus at the moment is under what we call a biodiversity action area designation. And this has all been done without increasing that grounds budget at all. It's just a different way of looking at it, a different way of managing what we've got. 2016, we developed a biodiversity action plan, and we're just about to revise that again now. So we've certainly got more plans on what we could do. And it's great because it's also led to much greater interaction between us and the academics, who've put in and managed to get some funding for something called the Living Lab, which is all about making use of university estate to do experiments and do research with benefits for the estate management, the academics and the students who get the hands-on experience, and potentially also involving the local community. So that woodland that I talked about, we've opened that up and we've made it accessible to the local community as well. One other little byproduct of this has been, and it's quite appropriate given where we started, has been that we've set up our own beehives on site, and our ground staff have learned and have got support on how to manage bees, and we produce our own honey, and we managed to sell 100 pots for charity last year, and we're looking to expand our honey production now. Very quickly, I'll just run through the last few things I wanted to say. We've done all this with a view to as much buy-in as we can from staff and students, and certainly setting up and getting certified to the environmental management standard ISO 14001, and after that we got on to the energy management standard as well, has meant that we've got that built into the management of the university. So from the Vice Chancellor down, there is this commitment to make environmental improvements, and a responsibility on all staff and all students to get involved. It can be quite onerous having this environmental standard, in the sense that you kind of set yourself up to be audited, and you've got to keep to the management policies and procedures that you put in place. So we get audited several times a year by BSI, by Lloyd's Register, to make sure that we are keeping to our policies and procedures. But it keeps us on the right side of legal compliance. It puts the emphasis on continual improvement, and it reduces the risks that we've got for the site environmentally. With waste, we managed the waste contract. That target of a 10% reduction in waste, we've managed to go further than that. We've probably, at the end of this year, we'll have achieved something like 20% reduction in waste. We've doubled the amount of recycling. Unhappily, we haven't tripled it, which is what we were aiming to do, but going forwards, obviously, we'll be focusing on that. We had a target to reduce our single occupancy commuting by 10%. We certainly have achieved that, largely through putting a subsidy into the local public bus service, and that's worked really, really well. The bus service is actually supplied by Hertfordshire University. They own Uno Bus, but we work with them very closely. They are based on site, and we now have a real benefit for the local community, because we have a regular public bus service which runs into the late evenings and at weekends. We also put in a cycleway to the village, which was crucial, given that the roads around here are quite narrow and quite busy and dangerous for students from other countries who are not sure which side of the road they should be on when on a bike. And I said about the environmental management system reducing risk. It's certainly something we emphasize to all staff and students when they come onto site first. And that is that anything that goes down a drain here on site will either go into Chichley Brook, which is monitored very closely by the Environment Agency, not least because we have a sewage treatment works that feeds into it as well, or it will go into that sewage treatment works and make a mess of that. So a lot of emphasis on making sure we control what goes down sinks and drains. No car washing. That picture of a car being washed, that's not allowed on site. And we really pay attention to trying to avoid any spillages that might end up, as I say, in Chicheley Brook, because it is very vulnerable. Right, this is the last slide. Just to talk a little bit about the future. So those original environmental targets were set for this academic year, which will for us end in July. Looking forwards, the University Executive and Council committed last year to new environmental targets looking forwards to 2030. Obviously more ambitious than the previous ones. And we're talking about net zero carbon by 2030, zero avoidable waste by 2030, 50% reduction in water by 2030. Biodiversity, we're looking at making sure that any new developments result in net biodiversity gain by 20% at least, with other environmental benefits. We're looking at further reducing that single occupancy car commuting to 50%. We've signed up to the Sustainable Development Goals the United Nations have set, and we're looking at a new climate change strategy. And on the back of the living lab I mentioned before, putting a lot more sensors in on site so that we can control pollution and at least get early warning, if not control what's going on in terms of spillages and pollution of that brook, for example, but air pollution and other issues as well. Biggest challenge for me is the carbon target. As I said, we're potentially going in the wrong direction with the combined heat and power unit at the moment. So we are looking very closely at our options, whether we can increase that solar farm, whether we can look at alternatives to that combined heat and power unit, and heat pumps is one area we're looking at. But also reevaluating what we're looking at in terms of our carbon footprint. So it isn't just our fuel usage and energy usage on site, it's also looking at what they call the scope 3 emissions. So it's what we purchase, how we travel, and other ways in which we impact on carbon. And of course, zero avoidable waste, another challenging target. Part of that will be working out what is avoidable and what isn't avoidable. So much more attention to detail to the waste streams that we have on site. And currently we do recycle about 16 or 17 different waste streams, but probably going into much more detail on how we can reduce or reuse for each individual waste stream. I'm starting to run out of voice. And that's probably a good job, because I think it would be very useful to have a bit of feedback and 1 or 2 questions.
Okay, thank you, Gareth, for that. Absolutely, really interesting. It's great to sort of see that, you know, when you talk about universities, you're immediately drawn to academic stuff and research stuff, but of course it's a business that's working and got a lot of infrastructure behind it. So it's really interesting to see that side of it, really. We have loads of questions. I don't think we're going to get through them all. Mark Andrews, do you want to unmute yourself and ask the first question?
Yeah, thank you very much, Gareth. That was a really great presentation. I'm a real believer in microgrids. I'm not a lover of the national grid. I think it's terrible that we take energy from Scotland and the northeast all the way down to the southeast. And so I wondered what your view is on the national grid. And you obviously are unable to really take advantage of it, but perhaps that's a good thing.
Yeah, I think possibly the combined heat and power unit has certainly made me think about what the potential is for our site. And I think the potential is that we could, in a sense, almost go off grid. I don't think we ever would. The REF base was originally built with 2 incomers coming from different parts of the local grid to give resilience. And I think obviously resilience is incredibly important for the university. We have quite high value research here and we don't really want any power cuts. But having said that, I think one of the focuses at the moment is looking at energy storage, both electricity and heat. And I think battery storage has come down in cost, and we're starting to experiment actually this year with one building where it will be backed up with some batteries from some electric buses that we've acquired and repurposed. But going to a bigger scale, I think we could potentially do that for the whole campus. And at least then that would give us more resilience, but it would also very much allow us to balance our energy mix and do more interesting things.
Yeah, thank you.
Okay, Alan Plum, you have a couple of questions.
Yep, hello there, sorry about that. Get myself unmuted. Yeah, inevitably my questions usually revolve around safety and health related issues. One specific one was really on the use of wood chips for, for fuel in the boilers. I know there's been problems with bulk storage. Have you had any difficulties in terms of flammability or safety?
We've had no difficulties whatsoever, other than our health and safety team did put some constraints on us, so that we do have to, before going in, even though that's a very short-term store and it's very well ventilated, then no one is allowed in there without doing gas checks on it, which is fair enough. But I think a lot of the safety concerns about wood fuel storage relating to gas, generally speaking, is either for longer term storage or storage which is much more sealed than the storage that we've got. So I think fairly confident that we haven't got an issue, but we have got the safety precautions in place just in case that issue might arise. Because I guess you never know what how you might change your operation that perhaps all of a sudden pushes you into a different situation.
I'm pleased to hear that, Gareth, because almost on our doorstep, actually, one of the big nurseries out by the A1 had a fatality, which I personally had to investigate exactly because of that. Somebody going into the back of a lorry,
right,
and was subsequently found asphyxiated.
Good grief. We
couldn't find out, quite the. I mean, we had assumptions, but yeah. So anyway, the precautions you've got are very, very wise. So congratulations to your colleagues. And actually, that leads on to another point. I mean, obviously we've got our office along with IAgrE in Cranfield, in the Bullock building, and I'm aware of everything that goes on, and we've had various visits with our local branch members over to different departments. But just when you summarize the enormous range of activities, as you said, you described it as a small town, and all the infrastructure being in effect your own as well. I can see a great opportunity with my health and safety background. I'm also a member of the Institution of Occupational Safety and Health, IOSH. So my question was going to be, who should I contact to arrange a talk, or preferably a visit when we get back to the old normal? I also suggested in that question, really looking at Charlie and my colleagues from the local branches, several of them are on the call. It will be a good opportunity actually for a joint visit. It's something we could almost, spend a good afternoon at anyway. And so really it was just exploring that possibility, Charlie, if you're okay with that on this call.
Yeah, Alan, no, you'd be very welcome. So yeah, I'd be happy to liaise on that, and yeah, if you tell me exactly the sort of things you'd be interested in, or the kind of yeah, whether there's anybody in the academic side here or somebody else in the States as well that you might want to be involved.
Yeah, it's got the potential to, be such a wide event. So we'd need to talk about how to rein it in a way. But we've had a tour of the welding section. That was absolutely fascinating, the work going on there. We've looked at quite a few of the work that we know and love, on the agriculture engineering side as well. But yeah, there's so many aspects to it. So we can talk about that outside of this meeting, I suspect.
Okay.
Holly.
Yeah, no worries.
Yeah, thank you.
Okay, Mr. Hurst, I apologise if I've got your name wrong, or you're not a Mr, of course. If you could unmute yourself. Question?
No, sorry, my name comes up. It's very strange, I think. Thank you very much, Gareth, for the talk this lunchtime. My question really was just basically your running costs of your biomass boiler on a yearly basis. Here, because I'm taking the place of John Shops here today for cheese. So we have a 450 kilowatt biomass boiler here that we've just installed in the last, well, we've had a previous one, we've just installed a new one. And we use pallets, etc., and old potato boxes. I just wanted to understand really what your running costs were for your biomass boiler for the year, on the wood chips that you're buying.
Yeah, a lot more expensive than your pallets, I think. Yeah, the wood chips, they work out just a bit more than the price of gas that we pay.
Okay.
So in a sense, that doesn't make economic sense. So we'd be burning wood chips, which are more expensive than the gas that they're replacing. But we do have a renewable heat incentive tariff. So that pretty much subsidizes the cost of the wood chips. And that's how we can justify, well, that's how we justify the business case, if you like, in the first place. It wouldn't have made sense without that renewable heat incentive.
No, of course. Thank you very much.
Okay, Tim Pratt, would you like to unmute yourself? Question?
Yeah, thanks, Gareth. On CHP, well, actually, PV, I think you mentioned that you couldn't export to the grid from the PV. I assume that's connected to the electrically to the CHP.
Yeah.
In essence, and getting the CHP in early, did you get export capacity for that?
No. Again, that was constrained.
Blimey. So when did the CHP go in again?
2010-11. Yeah, tail end of 2010.
Truth, I thought you would have got some in 2010, before all these people started throwing solar panels in and soaking up all the capacity.
As I say, I think it's a long-standing issue, and it's more to do with the fact that we're right on the edge of the network. That's what I was told at the time.
Okay, it can be worth asking again occasionally. They're starting to get slightly more intelligent with active network management and stuff. It is worth asking at times. Well, final question, just adding on to that. So have you pitched into things like capacity market with your CHP? Because you don't have to be able to export to the grid to get that.
No, I recognise that. But yeah, we did look at that a bit. I think the flexibility for being able to operate the CHP how we want to operate it, which has slowly sort of migrated from pretty much 24/7 to it interacting with the solar now to manage it on site. And I think the benefits actually coming through financially were not that huge for us.
Yeah, you see, it's an option. It jumps up and down. Yeah, I mean, latest auction 4 years ahead cleared about 18 grand a megawatt.
That's right. That's the sort of level that we were being told. But it was several. Well, for us, it was a few hoops to jump through, and somebody else, in a sense, dictating what we were doing.
Okay, no, fair enough. Thanks for that.
Okay, well, we probably need to wrap it up now. Got loads of questions, but we're running out of time. So thank you, Gareth, for taking some time out. That was really, really good. So just before we close, I'd like to thank you all for joining us today, and hope you will join us for our next lecture on the 20th of April, where we'll be joined by Craig Grant from Danfoss Hydraulics. Craig's going to talk to us about the next generation digital displacement hydraulic pumps with some pretty clever, unique technology inside, and how they can improve productivity and lower emissions. So all that's left to say is thanks again for everyone for joining, and see you again next time. Bye-bye.